The Six Shapes of Water Mini Course, Chapter 3, Voltage. Voltage measured in water is in the terms called millivolts, or MV for short. The balanced pH of 7.0 measures 0 millivolts. ORP stands for oxidation reduction potential, and I will pronounce as ORP for short. The oxidation reduction potential reading shows how much a substance is equipped for oxidizing or diminishing another substance. ORP reads in millivolts, MV, utilizing an ORP meter. A positive ORP demonstrates that a substance is an oxidized agent. The higher the level reading, the more significant oxidizing potential it has. Therefore, a substance with an ORP reading level of plus 400 millivolts has quadruple times more oxidizing power than the substance with an ORP reading level of 100 millivolts positive. A negative ORP reading level demonstrates that a substance is a reducing agent. The lower the reading level, the greater the anti-oxidizing power it has. Therefore, a substance with an ORP reading of negative 400 millivolts has several times more anti-oxidizing potential than a substance with an ORP reading level of negative 100 millivolts. Most sorts of water, including faucet or tap water and filtered water, are considered oxidizing agents as their ORP standards are positive. Alkaline ionized water is an antioxidizing agent containing a negative ORP level, which helps provide more electrons to kill the harmful impacts caused by free radicals circulating within the human body's cells. Most different kinds of water or beverages feature oxidizing agents, making their ORP positive and more damaging in the long run to the body. Now let's discuss about another version of voltage called ions and ion exchange. The ionic effect also determines the voltage. Ions are the polarity form of voltage, as a standard battery being positive, plus, or negative, minus. Cationic is a positive charged ion. Anionic is a negative charged ion. Non-ionic is the neutralized state of the ions where positive and negative ions cancel out one another. The following explanation by atlashighpurity.com explains the definition of what deionized water is, or DI water for short. Demystifying deionized water. How does it work? Natural water contains both positively charged ions, called cations, and negatively charged ions, called anions. In deionization, water flows through ion exchange resins that remove the cations and anions, resulting in DI water. It is important to note that deionization is not a filtration technology, but rather an ion exchange process that creates H2O. Ion exchange resins work like magnets, except they are small plastic beads. Each bed has organic polymer chains with charged functional groups. With its negative functional group, cation resin attracts positively charged cations, exchanging them for hydrogen, or H. Conversely, anion resin has a positive functional group that attracts negatively charged ions and exchanges them for hydroxyl, OH. When cation resin and anion resin release their respective hydrogen, H, and hydroxyl, OH, the result is H2O. Take a look at this image of deionized resin beads. The dark resin beads are the cations, while the light-colored resin beads are anionic. A cool scientific experiment is when you mix half cations and half anions together by stirring or shaking them up inside of a watertight sealed bag or jar. Waiting a few minutes allows the deionized mixture to settle like oil rising to the water's top. The light-colored anionic resin beads rise to the surface like bubbles in a carbonated beverage. The middle beaker in the image shows how the results appear after a few moments. This electrical arrangement is similar, but not precisely the same in theory in electrical polarity effects. By taking two magnets and trying to attract them with the same polarity, north to north poles and south to south poles, to each other. While opposites attract magnets, the matching poles push each other away. This electrical reaction is performing its nature of reorganization. Unlike battery polarity behavior, reorganization of deionized resin beads is a separation and regrouping of like properties, not opposites. Warning: some ion exchange resin beads use specialized stages which by themselves are not healthy to consume. This is why you don't drink softened water directly or water plants with that water type. Deionized water, like the dark and light-colored resin bead shown in the previous image, is often describing this ultra-purified water as hungry water, which pits and eats metallic surfaces just like a sponge absorbs water. DI water will leach out of your body all of the minerals it can find. Your body will go into survival mode and cause you to thirst so it can replenish your body with valuable minerals. This negative absorption effect is why you should never drink distilled water. It will just pass through your body, avoiding any benefits of proper hydration. The remedy is to have a point-of-use drinking water solution such as a reverse osmosis water treatment system or an ultrafiltration system that removes the residual dissolved salts left behind from the brine water solution regenerated by the ion exchange resin beads. Google provides images that show the ion exchange resin beads for water softeners. Ion exchange in water softeners is the most widely used application. In the process of ionic resin beads capturing hard water deposits, like attracting calcium and magnesium elements through adhesion, is similar to electric static cling on clothing that attracts hair, fur, and lint. When a water softener's ion exchange becomes exhausted from service, the ions must regenerate by soaking in a brine or salt water solution for some time. Then, fresh water flushes and rinses out the brine solution through the ion resin beads into a nearby sink or floor drain, completing the regeneration process. Now let's consider a dry version of differing ions reacting to each other. Suppose you ever stuck your hand inside of a box of powdered laundry detergent like Tide and tightly clenched a handful for a few seconds. It's like connecting a 12-volt battery with jumper cables and having the other end of the jumper cables produce sparks when the positive and negative clamps come in contact with each other. The laundry detergent features surfactants, which are surface active agents, to make water wetter. This chemical compound solution allows the soil on clothes to lift away from the garment when in solution with water. This chemical reaction of generating heat is the same effect inside the protective covering for pocket warmers. Water has its own form of electrical current preference, being cationic or positive. Generally speaking, consider anything not being electrically charged as ground, just like the ground that supports underneath you. Copper pipes are considered a good conductor of electricity and are negative ground by default. When unfiltered or untreated water comes in contact with a grounded surface, it creates water tension. Softened water removes hard water deposits that are left behind once the water evaporates. But before the water dries, its wetness forms into drops of water. The positive cations contained in the water electrically arc when landing on a negative ground surface, like your car's windshield or your vehicle's exterior body. This electric arc effect forms water droplets on those surfaces. And like the deionized resin experiment previously explained, they reorganize by consolidation, joining smaller droplets into larger drops. Two states of water occur when this happens. One is hydrophobic, which is water-hating. The other is hydrophilic, which is water-loving. You may have heard of products like 3M Scotchgard, and DuPont Teflon, and Tyvek or Gore-Tex, which create moisture barriers that repel liquids. You may have also seen new construction wrapping the building with an underlayment of Tyvek, another DuPont product, which is a moisture barrier that prevents condensation from rotting out the building's interior wall materials. All of these are good everyday examples of hydrophobic water surface tension in action. If you choose the final rinse at the end of your car wash sequence, you will be rinsing with softened water. Fewer water droplets means less moisture to dry off and fewer hard water deposits left behind after the exterior surface dries.